that a sales firm receives an average of 3 calls per hour on a toll-free number. For a given hour, find the probability that they will receive the following. All right, so for every single part, what's that 3? What does that 3 represent? It's my lambda, right? It's the average. So it's my mean for a Poisson, which we represent with lambda. X is going to be the part, their number that's in A, B, and C. So for A, at most 3 calls. That means that I want X to be less than or equal to 3. Now we said we could use the Poisson for this. We can also use our formula. Since I'm adding things up, it's the side my calculator can find. So I'm going to do a Poisson forgot some letters in there. CDF, where lambda is 3 and X is also 3. I can also use the Poisson formula for 0, 1, 2, and 3 and get that number. So, oh, I forgot to open my calculator. What'd you say it was? 0.647. 647? All right. So I want to get the number, which is my main thing, and then you're going to tell me what it means. So the probability of at most 3 calls in an hour is 64.7%. Questions on that? Yes.
Should we wrap it as 65%?
Well, you can. Yeah. Other questions? Yes. All right. So let me make this a little bit more visible. So we're going to go to our distributions area. So the second in vars, where it brings up the normal and all that stuff. And then we have to scroll down till we find our binomial. And there, mine's labeled under B. I don't know which one yours is under. Did you find? Poisson, that's right.
Oh, I was so confused.
Sorry, I'm messing up. We want to go to the Poisson, which should be under the binomial. So the Poisson CDF, and then it should ask you for your lambda and my x, which is 3. 3 and 3 for this one. And then when I calculate it, I should get to that. Did it work? You're welcome. All right, I want at least 3 calls. So that's the upper side that my calculator can't do, because x is greater than or equal to 3. So that means I'm going to have to do the 1 minus, and we're actually going to put in x equal to 2. So we're going to do 1 minus Poisson CDF, and we've got the mean is still 3, but my x I'm going to put in as a 2 so that it finds that complement amount that I'm not interested in. So I'm going to put my 1 minus first, do 1 minus, and then go find my function. You can run the function and do 1 minus afterwards. That's up to you. So let's go back to that same function that we just used. I'm going to leave the 3 for the lambda, but I'm going to change the x to a 2 and calculate. 5768. And what would you tell me about that? All right, so the probability of at least 3 calls in an hour is 50, if we want to round it to a whole number, 58%. Questions on it? All right, last one. 5 or more calls. So x is greater than or equal to 5. What's the x we're actually going to use in our calculator? X equal to 4. So we're going to do the same thing. 1 minus that Poisson CDF, where lambda is still 3, but we're going to put 4 in instead. And let's see what we get. 0.1847. So the probability of 5 or more calls in an hour is 18%, 18.5%, wherever you want to round to. I know on the homework I specify what decimal to take it to. Questions on that? Yes. Approximately 2% of people in a room of 200 people are left-handed. Find the probability that exactly 5 people there are left-handed. All right, so what do I have so far? What can I identify? I have a P. 0.02, all right. What's 200? N. All right. And exactly 5 is X. And exactly means equal. So we're equal to that amount, and it makes me think PDF. All right. So now what? Okay. So why are we doing that? Because it says exactly. Okay. And why did we choose binomial rather than Poisson? Because there is an n. Could we run a Poisson if we wanted to?
Technically, yes, you could because you need that.
I don't need that 200, but I do need a mean. Yes. Yeah, so we would take the mean for a binomial. That would equal my lambda. And we'd say the mean for a binomial was n times p. So 200 times 0.02 would give me a lambda to use. I think it gives me 4. Then I can say exactly, so I'm going to do a Poisson PDF of 4. Nope, yeah, lambda's 4 and x is 5. So I want to run both and I want to compare them. So let's run a binomial PDF and the Poisson. And let's see what we get. That's for which one? Okay, so 0.158. All right, let's see what we get for the Poisson. 6. What's the after the 6? 2.9. All right. So they're a little bit off. Both of them, if you rounded, would give you 16%. Why'd they come out so close? Why did they both work, I guess?
Because the sample size is fairly large.
The sample size is fairly large, and we can put the binomial in a Poisson when the sample size is large and your p is small. So generally, when your p is really small and you have a large n, the binomial tends to break down a little bit more and we go to the Poisson because the Poisson does not need an n. But if they're small enough, they're going to be similar. So they could both work. So on a problem like this, I would specify probably which one I want. If I wanted the Poisson, because I think most people, when you identify an n, a p, and an x, would go to the binomial. Probably on a test, I would expect that you will not be given an n for a Poisson. You'll only given a mean and your x. Doesn't mean they don't both work, but you don't have all the pieces sometimes. All right, so either way we do this problem, yes?
For this on a test, if we don't round to the exact whole number, would you do Poisson?
No. The only reason I said 16% is so we know they're the same. But I would probably leave one decimal. I usually take a percent with one decimal. All right. What would you tell me about this? The probability of exactly 5 people that are left-handed is, I'm just going to put it at 16% for now, so they match, but it is 16%. Questions on that? Yes?
Hold on, the other question is how exact you have to do it about? Is there like a leniency?
There is. I don't remember what the error is at the moment, but there is an error. I have an interval put in there.
Okay, so if we get like 21 by 7, it's still
It should, yeah.